What is it? Some may say it's the force that pulls us back to Earth when we are jumping. The dictionary defines gravity as the universal force of attraction between objects with mass. Gravity may also be defined as the tendency of objects with mass to accelerate toward each other. The gravitational force is one of the four fundamental forces in nature, the other three being the electromagnetic force, the weak nuclear force, and the strong nuclear force. The gravitational acceleration of the Earth endows objects with weight and causes them to fall to the ground when dropped. Gravity is also responsible for keeping the Earth and other planets in their orbits around the Sun, the Moon in its orbit around the Earth, for the tides, and for various other natural phenomena that we observe. There have been numerous theories of gravitation, starting with the ideas of the Greek philosopher Aristotle in the 4th century BC. He believed that there is no effect without a cause, and therefore no motion without a force. He concluded that bodies fell towards the center of the Earth in proportion to their weight. Building on these foundations, in 1687, English mathematician Isaac Newton published the famous Principia, which postulated the first ever law of gravitation. In 1687, Newton published his work on the universal law of gravity in his Mathematical Principles of Natural Philosophy. Newton's law of gravitation states that every particle in the universe attracts every other particle with a force that is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. If the particles have masses m1 and m2 and are separated by a distance of r, the magnitude of this gravitational force is F equals g times the quantity of m1 times m2 divided by r squared, where g is the universal constant called the gravitational constant. This means that, ignoring air resistance, an object falling freely near the Earth's surface increases in speed by 9.8 meters per second for each second of its descent. If every particle exerts a force on another particle, this means that every object in the universe attracts and deflects other objects. The Earth itself experiences an equal and opposite force to that of the falling object, meaning that the Earth also accelerates towards the object. However, because of the immense mass of the Earth, this acceleration is very, very small.
All right, watch this.
What the hell? What is this? What is this, some kind of gag?
No, that's orbit.
Huh?
You have your own gravitational pull.
Oh, that's a bunch of crap.
Now back to the Three Stooges.
Oh.
Newton's law of gravitation simplifies to F equals mg, where m is the mass of the body. This assumption is reasonable for objects falling to Earth over the relatively short vertical distances of our everyday experience. Gravity affects you every day. As these children on this playground demonstrate, gravity is everywhere. When this boy gets too tired on the monkey bars, he falls down because he can't support his weight against the pull of gravity. When they slide down this pole, they accelerate down due to gravity. The gravitational force pulls on these boys as they go down the slide as well as when they are skateboarding. If they don't apply enough energy in the X direction as they are going up the ramp, the gravity, which is acting in the Y direction as denoted in this chart, their skateboards will go back down the ramp because of the increase in the force in the Y direction.